Welcome back, ladies and gentlemen. We're going to start working on day 3 of the Chapter 19 notes. Today, we're going to be focusing on pH and pH calculations. So first off, what is pH? Well, in water, the concentration of hydrogen is equal to the concentration of hydroxide. This is why water is considered to be a neutral substance because they are equal to each other. In an acidic solution, you have a greater concentration of hydrogen ion. And in a basic solution, you're going to have a greater concentration of the hydroxide ion. So what pH really does is it looks at the concentration of your hydrogen and hydroxide ions and tells you what type of substance you have. Now, to get to that point, we have to look at a couple of different ideas. Now, water. Water has a very low ionization. It naturally ionizes or breaks down into the hydrogen ion and the hydroxide ion. So if we looked at writing the KEQ or KW for water, it's going to be the concentration of hydrogen times the concentration of hydroxide. We don't include our reactant of water here because it is a liquid. At 298 Kelvin for pure water, the concentration of hydrogen and the concentration of hydroxide both equal 1.0 times 10 to the negative 7th molar. Very small concentrations. If we plug those values into our KW and we calculate this, then the concentration of hydrogen times the concentration of hydroxide ends up equaling 1.00 times 10 to the negative 14th. That is the KW or the KEQ value for water. Because hydrogen and hydroxide are such small numbers, their concentrations, as you can see there, 1.0 times 10 negative 7th is a very small concentration. Scientists invented the pH scale to simplify these odd numbers. And that's what you're seeing here. So at a neutral solution, our concentration of hydrogen and hydroxide are equal to each other, 1 times 10 negative 7th molar. And at that value, our pH is 7. So when pH is equal to 7, we have a neutral solution. Anything that is less than 7 is going to give us an acid. As you can see here, anything less than 7 would be acidic. And anything greater than 7 is going to give us a basic solution. Now, the pH scale goes from 0 to 14, but it is not just limited to 0 to 14. Anything below 0 would be an acid still, and it would be an extremely strong acid. A pH of 0 is a very strong acid, so anything below that would be very strong. A pH of 14 would give you a very strong base. You can go above 14 for very, very strong bases, ones of high concentration. So this scale shows 0 to 14, but technically you can be below or above that value too, depending on the concentration of hydrogen and hydroxide in the solution. How are pH and pOH related? Well, pH is dealing with the hydrogen ion concentration. pOH is dealing with the hydroxide ion concentration. They are inverse of each other. So pH plus pOH is equal to 14.00. For example, if I'm given a pH of 6, then my pOH would be 8. 6 plus 8 is 14. Where does pH come from? Well, the P in pH stands for the negative log of the hydrogen ion concentration. So this is how you're going to calculate pH values. pH is minus log of the hydrogen ion concentration. How about pOH? Well, the pOH is the negative log of the hydroxide ion concentration. That's why it's called pOH instead. So pOH is going to be minus the log of the hydroxide ion concentration. All right, since we are using logarithms, we have to remember our rules with logs and sig figs. We saw this back in chapter 18 when we were doing rate laws. When you take the logarithm of a number, it has as many decimal places as the number of sig figs of the original number. So for example, here I have 2 sig figs. When I take the logarithm of that number, my answer will have 2 decimal places. Okay, so if I take the log of a number, however many sig figs it has is going to be equivalent to how many decimal places your answer will have. Now, if I do it in the reverse order and I take the anti-log of a number, it's going to have as many sig figs as there is decimal places. So in 8.49, I have 2 decimal places, which gives my answer then 2 sig figs. So we do these pH calculations, we'll be looking very carefully at our number of sig figs and decimal places with our answers. Now, we just saw something there mention anti-log of a number. Well, if I'm given pH or pOH, I can also find the hydrogen ion and hydroxide ion concentration. We're going to do the opposite. We're going to take the anti-log of the pH. Now, on your calculators, the anti-log is the second log button. So if you look on your calculator, you'll see your log button. Above that, you see 10 to the x power. That is your anti-log button right there, okay? So to get the concentration of your hydrogen ion, what you're going to do is you're going to take the anti-log of the negative pH value. And to find your hydroxide ion concentration, you're going to take the anti-log of your negative pOH value. So what it ends up looking like, and I need to erase this. So what it ends up looking like would be 10 to the negative pH equaling your hydrogen ion concentration, or for pOH, it would be 10 to the negative pOH value, and that equals your hydroxide ion concentration. Now, to do these class practice problems, you need a calculator in front of you. Please, please, please punch these numbers in and double check your work. When you're working on the pH Google form that I prepared for you guys, have this in front of you to help you. These are the 6 equations that you need to know for your pH calculations. These are very important equations. Sig figs don't really pertain to this. So don't let like this answer here, this number, limit your number of sig figs. The same with 14.00. Don't let that limit your number of sig figs. We're going to follow the rules with logarithms and decimal places to be able to figure out your number of sig figs for your answers. So the first problem we see here is the pH is 12.22. I would go and figure out my pOH then. That's the easiest one to do. So I'm going to take 14 minus 12.22. When I do that, I get a value of 1.78. Now, to figure out my hydrogen ion concentration, I'm going to use 12.22. To figure out hydrogen ion concentration, you have to take the anti-log of the negative pH. So I'm going to take the anti-log of negative 12.22. Now, when I do that, I have to figure out my number of sig figs for my final answer. So this number here has 2 decimal places. Therefore, my answer will have 2 significant figures. 6.0 is what it rounds to, times 10 to the negative 13 molar. Okay. Let's see here. I'm going to change colors for the next one. And maybe I should kind of do this. So to figure out my hydroxide ion concentration, I'm going to use my pOH now. So to find the hydroxide concentration, you're going to take the anti-log of your negative pOH. So I'm going to take my anti-log, which is 10 to the power of negative 1.78. Remember, your second log button is your anti-log button. Now here I have 2 decimal places, so my answer will have 2 sig figs. It rounds out to be 0.017 molar. Now my concentrations all have units of molarity. My pH and my pOH do not have units to them. This last column of identifying acid, base, or neutral, we'll go back and do that at the end. All right, so the next problem we see here, I'm given my hydrogen ion concentration. From the hydrogen ion concentration, I can find pH. pH is minus the log of my hydrogen ion concentration. So minus the log of 1.0 times 10 to the negative 7. Now, looking at this, I have 2 sig figs in that number. So my answer will have 2 decimal places. My answer comes out to be 7. But to write it with 2 decimal places, it will be 7.00. To figure out my pOH, remember pH plus pOH equals 14. Well, 14 minus 7.00 is again 7.00. To figure out my hydroxide ion concentration, I'm going to use that 7.00. Hydroxide concentration equals the anti-log, so 10 to the power of my pOH value, negative 7.00. I have 2 decimal places with that problem, so my answer will have 2 significant figures. That comes out to be 1.0 times 10 to the negative 7th molar. For solution 3, I am given the pOH. Well, pH is just going to be 14 minus my pOH, 13.4. That comes out to be 0.6. To find my hydrogen ion concentration, I'm going to take the anti-log of that value. So the anti-log of negative 0.6. Excuse me. So now I have 1 decimal place with that pH value, which is going to give me 1 sig fig for my answer. So that would come out to be, with sig figs, 0.3 molar. To figure out my hydroxide concentration, I'm going to use my pOH value. Again, I'm going to take the anti-log. That's a 10. Oh, really? No, let me fix that. That is going to be the anti-log to the negative pOH value. So 10 to the negative 3.4 there. Again, I have 1 decimal place, so my answer will end up with 1 significant figure. That comes out to be 4 times 10 to the negative 14th. And my unit there would be molar. All right, looking at our next problem. This time we're given a hydroxide ion concentration. From hydroxide concentration, I can find my pOH. I do that by taking minus the log of my hydroxide concentration, 7.1 times 10 to the negative 13. So when I type that in, I'll get my number, and then I got to round it to the correct sig figs. Because I have 2 sig figs here, my answer will have 2 decimal places. That is going to round to 12 12.15. Now that I know my pOH, I can find my pH. It's just going to be 14 minus 12.15. When I do that, I get 1.85. From my pH, I can now find my hydrogen ion concentration. I'm going to take the antilog of the negative pH value, so 10 to the power of negative 1.85. That number has 2 decimal places, so my answer will have 2 significant figures. That comes out to be 0.014 molar. All right, now we're going to look at solution number 5. With solution number 5, I am given a pH. From that pH, I can calculate my pOH. 14 minus 5.71. That comes out to be 8.29. From that pH, and let's change colors here, I can also figure out my hydrogen ion concentration. And from this pOH, I can figure out my hydroxide ion concentration as well. So let's go ahead and do that since I'm already in red here. So to do that, I have to take the antilog of negative pOH, which is going to be the 10 to the negative 8.29. That number there has 2 decimal places, so my answer will end up with 2 significant figures. That comes out to be 5.1 times 10 to the negative 9th molar. Now to find my hydrogen ion concentration, I am going to use my pH. To find hydrogen ion concentration, it is the antilog of my negative pH value. So it's going to end up being 10 to the negative 5.71 power. And when I type that into my calculator, I'm going to round my answer to 2 sig figs. I have 2 decimal places here, so my answer will need 2 significant figures. That rounds to 1.9 times 10 to the negative 6 molar. All right, last solution here. In this last solution, I am given a hydrogen ion concentration. From my hydrogen ion concentration, I can find my pH. pH is minus the log of my hydrogen ion concentration. So it's going to be minus the log of 1.75 times 10 to the negative 2. Now this number here has 3 sig figs. So that means my answer will have 3 decimal places. That rounds to 1.757. Now to get my pOH, I'm going to take that answer and subtract it from 14. 14 minus 1.757 comes out to be 12.243. And again, since that had 3 decimal places, this number will also have 3 decimal places. All right, now that we have our pOH, we can now find our hydroxide ion concentration. To do that, we have to take the antilog of the negative pOH, which is 12.243. So 10 to the negative 12.243. That number has 3 decimal places. Therefore, my hydroxide concentration will have 3 significant figures. When I type that in, I get 5.71 times 10 to the negative 13th molar. Okay, now notice I never used this calculation. That does not mean you don't have to use that calculation. You definitely can. When I teach this normally in class, I teach it the way I just showed you. because kids have to memorize all 6 of these equations. I think it's a little bit easier if you just know the other ones without having to memorize one more equation. So that's why I show it that way. But you definitely can use that equation too. You should get to very close to the same answers. Sometimes because of rounding and sig figs, they might be a little different, but not much different at all. All right, the last idea that we're going to look at here is identifying, is it an acid, base, or neutral? Remember, if it was an acid, your pH is going to be less than 7. If it was neutral, it was right at 7. And if it was a base, your pH is going to be greater than 7. So we always want to go back and look at what the original pH value was. For the first solution, it's 12.22. That is greater than 7. So our first solution is a base. Our second solution is right at 7. That would make this solution neutral. Solution number 3, our pH is at 0.6. Well, 0.6 is less than 7, so that solution is an acid. Solution 4, our pH is 1.85. Less than 7 makes our solution an acid. Solution 5 is at 5.71. pH is less than 7, so that solution is also an acid. And the last problem, solution number 6, has a pH of 1.757. Also less than 7, so that also makes that solution an acid. That is it for our notes today dealing with pH calculations.